All right, as far as if you haven't progressed beyond just looking at this, okay, here would be the next potential step. Okay, draw in the information that's provided. So if we draw in a radius of 8 and a radius of 3, okay, there's a couple things that we know. We also know that the centers are distance of 22 from each other. So if I draw in this length or this distance connecting the centers, I know that that whole length is 22. Okay, is there anything else that I know that's not related in this diagram yet? How do radius and tangents intersect? They form a right angle. Perfect. So I also know this, right? That these are right angles here. Okay, and so in looking at these, I have these two right angles. Not only do they share an equal 90-degree angle, they also have this pair of vertical angles that are the same. And so now using the AA similarity, I know that I have similar triangles, right? Okay, so see if you can use similar triangles and the properties associated with that to come up with a solution for finding x. Again, I'll give you about a minute to do that. And then, so here's a couple different ways you can approach this problem. They're both based on the same concept. They're done just slightly different ways depending on how you think individually, how you approach these. All right, so if you know that these are similar triangles, that means that they have a ratio of parts that's consistent, right? And the ratio of parts is what to what? You see that these pieces line up, match up, so it's the ratio of 8 to 3. All right, so you can do a couple different things here. Okay, the easiest thing, in my opinion, is they give you this whole length of red here. And so you know that whole length of red is 22. And if the ratio of parts is 8 to 3, how many total parts are there? 11. So that means that this portion from here to here is 8 parts out of the total 11 of the whole length 22. And so what does that actually equal? 11 goes into 22 too. 2 times 8 is 16. So this length is 16 of that 22, which leaves what for this length? The remaining 6, which we can also confirm. Again, if its ratio is 3 parts out of the whole 11 times the entire length 22, that confirms 3 times 2, which is 6. So you get these two lengths here to be 6 and 16. And so what you can use now to find the pieces of x for each of these lengths. So this piece of x right here for the larger triangle, if you use either Pythagorean theorem or what do you notice about this triangle? You have a leg of 8 and a hypotenuse of 16. Does that relate in any way to special triangles that we've looked at? Yeah, it's actually a 30, 60, 90, right? So you actually know more about this triangle. You have an angle of 30, 60. So that means if the side opposite 30 degrees is 8, what does that have to be, or what length is the side opposite 60 degrees? 8 root 3. The same thing for this triangle up here. You have this 30, 60, 90 triangle. If the side opposite 30 degrees is 3, what does that mean the side opposite 60 degrees is going to be? 3 root 3. And so our whole length x is going to equal 8 root 3 plus 3 root 3 or 11 root 3. And so that would be our answer. All right, there's another way that you can possibly approach this problem. And what that is would be the following. Okay, you're still looking at this. You have this red length here that's 22. Okay, so you know that this whole length here is 22. I'll label it right here. Okay, if you were to extend this side down and form this little rectangle right here. So if we extend it down and connect it to the center of this other circle, so that we formed this little rectangle in purple here. And what properties do you know about a rectangle? Opposite sides are equal. So if this length here is 3, when I look across the way, this same purple length is 3. So what's this whole leg of that large right triangle going to be? 11. And so now if we look at this big right triangle here, we have a hypotenuse of 22, we have this leg of 11, and the only thing left is this length. Again, opposite sides are equal. It's equivalent to x. And so looking at this large triangle, again, we have this leg of 11. The hypotenuse is double that. So that means this angle is 30 degrees. We have this 30, 60, 90 triangle. So if the leg opposite 30 degrees is 11, that means the leg opposite 60 degrees has to be 11 root 3, which is our length x. So you can think of it either of those ways. Either similar triangles, I did that one so that you get some practice using similar triangles, but this other one is probably easier if you're able to see it and build out the triangle and just use straight Pythagorean theorem, in this case the special triangles.